Oh, good. I don't know. What is it? It's good afternoon. Good evening. Hey, everybody. Yeah, I am actually okay. Let me see if I can. Hmm? I'm excited. Like this, Zelda is coming, right? The new game. um. Well, hello. Hi, everybody. I can see. Okay, what do we got going on in chat over here? Um. Hello. Hi. Hello. Wow. Lots of nice people here. Hello. Hello. Whoopsie. Let's see. Good to see you. Hello. Hi, I'm here. I was here. I was distracted, uh, making, refilling my water flask. Hello. Hi. What does marhaba mean? Whatever it means, I think it sounds nice. So I'm hi. Hello. 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 Hi, everybody. Happy, I don't know where you are in the world. It's probably Monday in some parts of the world. It's certainly Sunday where I am, and in anything west of here is now well into Sunday. So hello, um, hi, thanks for joining everybody. Good stuff. Oh, welcome. Oh, hi. That's a nice word. Thank you for teaching it to me. So marhaba. I'm sorry if I mispronounced that. Uh, I don't know what I'm saying, so I'm sorry, but it sounds very beautiful. Very, very, very nice. Thank you for teaching me that. Welcome. Hello, friends. So I was just trying to enjoy my weekend, and I flew from the U.S. Here to Athens, Greece, which is oh so beautiful. It's every time I come here, I'm just like, oh, I should move here. It's like it reminds me of Barcelona. Barcelona and I mean anywhere in the Mediterranean area, Italy, Greece, Spain, all of it is just beautiful. And so here I'm in Athens, Greece, and I went to Devoxx Greece. A fantastic show. Good job, everybody. Well done. Bravo. Let's give them a round of applause. Claps for them, I say. Claps, I say. Just a wonderful show. Great experience. Great to see amazing speakers from whom I learned a lot there as well. Anyway, so I got here, did the whole thing on Saturday. I spoke yesterday, believe it or not. The conference ran over the weekend. Well, Thursday, Friday, and then Saturday. And I was just trying to focus on being present in Greece. And then I go on the internet a couple days ago, and I was like, oh, hey, the internet's on fire. What's going on? And apparently we've had this revelatory moment where we've decided that we should think about architecture, and predictably, it has not gone over well. So let's talk about this ridiculous, wonderful blog that I think I will frame and keep enshrined forever in my heart. Here we go. Let's see. Share screen. Um, do. All right, here we go, friends. Here it is. It's happening. Did it work? Okay, good. You can see it. Hi, hello, good to see you, and I appreciate that. Hello, hola, hello. So, okay, here's this blog. Here's this ridiculous blog that should have been like in the Onion, or something like that. Like the duh, like come on. I'm trying not to be too snarky. Um, but this one just blows my mind. Uh, okay, wait. Quick distraction. Buddy, don't worry. Nobody is actually up to any good level of coding, or rather, as good as anybody might be at one particular thing. There are countless other things in which they're terrible. And if you're 2 years into university and you feel like you know nothing, that's fine. That's honest. Uh, what'll separate you, what'll keep you ahead of the pack, is if you get 20 years into your career or more, like I have, and still think you feel like you know nothing. Right? That's the trick. Is just remember you don't know anything, and I don't know anything. It's okay to be completely honest about that. It's actually really good for the health. It's good for the spirit to just be very honest about how oblivious most of us are to the latest and greatest. So it's fine. Don't worry about it. Just keep learning. That's the only thing you can do. Coding is there's no such thing as coding. There's like programming in a particular language with a particular paradigm. But just as good as you might get in that, you might might fall short in another language with a different paradigm, right? Yeah. Okay, moving on. We got some questions here. Yeah. Okay, good. So let's talk about this blog. Okay, this hit. When did this drop? I don't even know. It just Whoa, all I know is that there. Oh, March 20. No, that's. Oh, is that? Is this? So this is from March of this year, 3 months ago, friends. Two months ago. I guess I'm just excited about summer being here, and I leapt ahead. Um, yeah. So, so March of. I didn't even know. Um, so this blog just got like the notoriety that it deserves in this last week. It's just everywhere. And basically, let's just talk about it, okay? Let's just think about what this blog is saying, and it'll seem absurd that this bears repeating or even discussion, and yet here we are. At Prime Video, by the way, I don't know how prolific Prime Video is. Amazon has like a streaming service from which you can buy movies and TV shows, but they also have a free right? Basically, you pay for their subscription, and basically it's like Netflix, but by Amazon, right? Oh, that's great. Love from South Africa. I love South Africa, and hello to you from just above North Africa. Just a little bit, just a very quick flight. So at Prime Video, we have offered thousands of live streams to our customers, right? And to ensure that customers seamlessly receive content, Prime Video set up a tool to monitor every stream viewed by customers. This tool allowed us to automatically identify perceptual quality issues. For example, block corruption or audio video sync problems and trigger a process to fix them. Go on, right? Not a big deal here. So far, we're all on the same page. Our video quality analysis team at Prime Video already owned a tool for audio video quality inspection, but we never intended nor designed it to run at high scale. Our target was to monitor thousands of concurrent streams and grow that number over time. Fair. While onboarding more streams to the service, we noticed that running the infrastructure at high scale was expensive. By the way, Amazon Prime is a service provided by Amazon, the same one that provides Amazon Web Services. I know this is obvious to you, but it's all Amazon, right? It's all one big multifaceted company here. Okay. So, but we never intended nor designed it to run at high scale. Our target was to monitor thousands of concurrent streams and grow that at that number over time. While onboarding more streams to the service, we noticed that running the infrastructure at a high scale was very expensive. We also noticed that scaling bottlenecks prevented us from monitoring thousands of streams. So we took a step back and revisited the architecture of the existing service, focusing on the cost and scaling bottlenecks. Which is right, by the way. That's the way to do it, right? Get it working, then get it fast. In that order, always, right? Get it working, then fast. And do it with the idea that you might have to make compromises. You might have to make concessions. That's just going to happen, right? We know that. Anybody who's done anything knows that you build one and then throw it away, right? The second version is probably going to be the one you keep in production. Okay, so the initial version of our service consisted of distributed components that were orchestrated by Amazon Step Functions, AWS Step Functions. Are these lambdas? What is this? Is this another way of saying Amazon Lambda? Let's go see what that is. Amazon AWS Step Functions functions is? No, wait, that can't be right. R? I'm going to go ahead and say R, okay? I don't know if that's right. It feels like it's a plural, right? Okay, whatever. R, a serverless orchestrate. Now I don't know. Is it is or ours? I don't know. This language is goofy. Okay, so accepting all cookies. I'm in Europe. I get it. Amazon Step Functions are a serverless orchestration service. Oh, it is a. I guess it's the product name. Okay, so Amazon X is a serverless orchestration service that lets you integrate with Amazon Lambda. Wait, is it not? Functions and other AWS services to build business critical applications through step functions. Oh, so is it Amazon Step? Okay, I hate this. Through X's graphical console, you see your application's workflow as a series of event-driven steps. Step functions X are based on a state machine and tasks. On state machines and tasks. A state machine is a workflow. A task is a state. Oh, okay. We get it's a directed graph. Great. With X's built-in controls, you examine the state of each step in your workflow to make sure the application runs in order. So is it just an orchestration for Lambda? Okay, moving on. Let's just assume it's something related to lambdas. Okay, and lambdas famously are a way to take a whole warehouse of computers so that you can run word count. Right? It's interesting. So the initial version of our service consisted of distributed components that were orchestrated by Amazon's AWS's step functions. The two most expensive operations in terms of the cost were the orchestration workflow and when data was passed between distributed components. To address this, we moved all components into a single process to keep the data transfer within the process memory, which also simplified the orchestration logic. Because we compiled all the operations into a single process, we could rely on scalable Amazon EC2 and Amazon Elastic ECS instances for the deployment. Okay, so this is their VM compute thing, and this is their container thing. Okay. Oh, okay, Airflow. It's like Airflow. Okay, like Apache Airflow. Couldn't they just say that? Why? I don't. Okay. Instances for the so it's not the same as Airflow, right? It's just like it. Oh yeah, it's like it. Okay. I don't know. I think I feel this is one of those things where I feel like maybe a little conversation with some open source people would have helped them out a lot. Okay, whatever. So moving on. Distributed systems overhead. Our system consists of three major components. The media converter. It converts input audio and video streams to frames or decrypted audio buffers that are sent to detectors. All right, so far so good. So that is FFmpeg, right? That's got to be. I sure hope that somewhere in the bowels of that machine is just a very tiny little FFmpeg job, okay? Defect detectors defect detectors, say that 10 times fast, I dare you, execute. Oh, that's a bummer. As I'm talking to you, I just saw a headline that says San Francisco real estate prices are still declining. Is it a sign of the doom loop? Oh, it's okay. Defect detectors execute algorithms that analyze frames and audio buffers in real time, looking for defects such as video freeze, block corruption, or audio-video synchronization problems, and send real-time notifications whenever a defect is found. For more information about this topic, see our How Prime Video Uses Machine Learning to Ensure Video Quality article. Okay, great. The third, and by the way, maybe that's a thing we should be doing right now. This feels like it would probably give me a lot more insight than the crux of this particular article. The third component provides orchestration that controls the flow in the service, okay? So we designed our initial solution as a distributed system using serverless components, for example, Lambda, which was a good choice for building the service quickly, right? Build it, get it working, then optimize. In theory, this would allow us to scale each service component independently. Right, good. Okay, that's okay. Yeah. However, the same way we used some components causes us to hit a hard scaling limit at around 5% of the expected load. Wait, so what does that mean? What does that mean? That means that they've got components that hit a saturation point, which meant that they couldn't go any higher. Why? I don't understand that sentence yet. Also, the overall cost of all the building blocks was too high to accept the solution at a large scale. So what they're saying is Amazon Web Services X is Amazon Web Services are, I don't know, AWS is expensive, right? Also, yeah, that's it. Okay, this is not news. I feel like that was okay. Moving on. What's great about this blog, my friends, is again, this is Amazon telling us what we've all known. They're saying the quiet part out loud, which is the cloud's expensive. That's sort of the reason it works, is because it's, you pay them money. They have the ability to develop economies of scale. And in theory, that economy of scale, while expensive, translates into cost efficiencies for you if you're doing things in a sensible way. When you start deploying a new virtual machine to run a function, however, yeah, things are going to stack up pretty quick, right? Okay. Also, the overall cost of the the overall cost of the building blocks was too high to accept the solution at a large scale. The following diagram shows the serverless architecture of our service. Okay, so okay, so customer, that's us. Somebody wanting to watch a video, I guess. Amazon, so we hit the Amazon Lambda entry point, and that does a fork where we step functions detector 1, 2, so we're detecting flaws. The results get sent out to another Lambda to do aggregation. So this is like, we talked about Spring integration. We have a Let's Code series. This is all stock standard, like integration kind of stuff, right? Or even workflow if you used activity or the like, okay? Okay, Amazon Lambda result aggregation, send the results to S3 as a staging buffer, right? Okay, good. So you need you need to dump the result somewhere, okay? And then this, so wait, the aggregation gets dumped into this bucket, but the individual output of a particular detector also goes to Lambda. And then if we start the conversion, I don't understand what's happening. So we hit the Lambda entry point. What conversion is happening here? Did I miss something? This is monitoring a stream viewed by customers. Okay. I assume this is like in the ingest, like maybe a studio sends them a movie and they want to put it in their system. There's a whole flow to normalize the content and get it ready for people to stream. Feels like, okay. I don't know. I have no idea. So the main scaling bottleneck in the architecture was the orchestration management that was implemented using AWS step functions. Our service performed multiple state transitions for every second. What? Wait, okay, service, but it's still within the same VM. Okay, that seems in the same process, in the same JVM. Okay, so the detector reads the left bucket, this thing here. It looks like it's dumping something out to that. I don't know, but you're right. Either way. Oh wait, what is this? SNS custom. Oh, that's notifications. Okay. Um, the main scaling bottleneck in the architecture was the orchestration management. Our service performed multiple state transitions for every second of the stream, so we quickly reached account limits. Besides that, AWS step functions charges users per state transition. What blows my mind here is you'd think that Amazon would cut themselves like a discount or something. You know, it is. I mean, I'm sure they're not getting. I hope they're not getting charged the markup price. You'd think it'd be like wholesale for within the family kind of discount. You know, one arm of the business. Feels weird. Okay, second cost problem we discovered was about the way we were passing video frames, images around different components. To reduce computationally expensive video conversion jobs, we built a microservice that splits videos into frames and temporarily uploads images to an Amazon S3 bucket. Defect detectors, where each of them also runs on a separate microservice, then download images and process concurrently using Amazon Lambda. However, the high number of tier 1 calls to the S3 bucket was expensive. Okay, what does tier 1 mean in the context of this? Is it just like within the same LAN or something like that? Same account? I don't know. From distributed microservices to a monolith application. To address the bottleneck, we initially considered fixing problems separately to reduce cost and increase scaling capabilities. We experimented and took a bold decision. We decided to re-architect our infrastructure. There it is. It's not bold, by the way. That's just it's okay to admit you're wrong, right? Build it and then make it right and make it fast. We realized that distributed approach wasn't bringing a lot of benefits to our specific use case. So, and not to mention, I don't think there's any value in, you know, I have yet to find a situation where the upkeep, overhead, cognitive overhead, and management and deployment of a function is just so vastly preferable to just deploying a service, right? A standalone service. It certainly makes maintenance and upkeep and your operations playbooks more valuable, you know, to just do it as a service. Okay, so we realized that the distributed approach wasn't bringing a lot of benefits to our specific use case, so we packed all the components into a single process. This eliminated the need for the S3 bucket as the intermediate storage for video frames because our data transfer now happened in memory. We also implemented orchestration that controls components within a single instance. Okay. The following diagram shows the architecture of the system after migrating the monolith. Okay, so customer, start, analyst, it's all one big monolith, right? Oh, it's all within a single ECS task. What is that? What is an ECS task? Is that like an API? Is it like a service? Amazon ECS. You can just run containers on demand. What is that? Okay, a task is a definition required to run Docker containers in Amazon. Is it like just a job, like a job in Kubernetes or something? Docker image to use, how much CPU? Uh, okay. Okay, so it's just a container that you get to run. Okay, great. So moving on. So customer orchestration hits the endpoint or whatever, starts the conversion, sends it to the media converter. The data goes back to the orchestration layer. Then that does some analysis and they get sent over to the detectors. There's a conversion that happens. We saw that. Okay. Memory, instance memory. What is this gray box intended to indicate? And then the final results go into the result aggregation. Fair. Good. Conceptually, the high-level architecture remained the same. We still have exactly the same components as we had in the initial design: media conversion, detectors, and orchestration. This allowed us to reuse a lot of the code and quickly migrate to a new architecture. Yeah, good. And that's a sign, by the way, of a well-done architecture, right? That's the same. That's, I mean, I always talk about this, right? If you're, uh, try building a majestic monolith. Looking at like projects like Spring Moduliths, right? And then if you're layering types by feature and not by package or not by role, I mean, then it'll be natural to then scale it if and when that need should arise. But start with a monolith. Okay, good. And if you do that, both ways, the code is you want your code to be well designed. That's the whole point here. That's very important. It doesn't matter if it's distributed. If it needs to be, it can be, but don't foreclose upon that possibility by using bad design at the monolith level. Conceptually, the high-level architecture remained the same. We still have exactly the same components. This allowed us to reuse a lot of the code and quickly migrate to a new architecture. Great. In the new architecture, we could scale detectors horizontally as each of them ran as a separate microservice. So adding a new detector required creating a new microservice and plugging it into the orchestration. However, in our new approach, the number of detectors only scales vertically because they all run within the same instance. Our team regularly adds more detectors to the service, and we already exceeded the capacity of a single instance. To overcome this problem, we cloned the service multiple times, parameterizing each copy with a different subset of detectors. We also implemented a lightweight orchestration layer to distribute customer requests. Hmm. So my understanding that they've got like a single process that has a number of detectors, and like they've just they have like a like this it's all the same binary. It's the same process across 1,000 nodes, but maybe these 20 have these 5 detectors and that 20 have another 5 detectors or something like that. Is that what I'm understanding? Start analysis, hit the lambda. What is this? Is this the original? No. Start analysis, hit the lambda, go to ECS, go to the Amazon ECS service for detectors 1 and 2. Yeah. Okay. So you've got is it the same app though, right? They're the same apps. They're just toggling a flag to enable these and that and whatever. And then the results go to the S3 bucket. Okay. Results and takeaways. Microservices and serverless components are tools that do work at high scale, but whether to use them over a monolith has to be made on a case-by-case basis. Moving our service to a monolith reduced our infrastructure cost by over 90%. Oh, wow. That's, I mean, it is inflation's it's a problem, but this is a good thing right here. Look at this. This is deflation or something. Good idea. Well done. Can you imagine having like there are very few things you can do to get a single payday worth 90%. One of the reasons that I love GraalVM is because if it works, if you can turn it into a native image, if you can turn your Spring Boot application into a native image, in theory, you could get as much as like 90% RAM reduction, right? It's not gonna be free. I mean, conceptually, you're gonna probably have a few days of like trying to make your code native and make it work. But again, 90% reduction in footprint. That's nice. That's rare. That's a once in a generation opportunity there. And looks like you can get the same by just ditching lambdas here. Okay. It's also increased our scaling capabilities. Today, we were able to handle thousands of streams, and we still have the capacity to scale the service even further. Um, Moving the solution to Amazon EC2 and Amazon ECS also allowed us to use the Amazon EC2 compute savings plans that will help drive down costs even more. Okay, good. Amazon is clearly making inroads to provide a cheap, affordable, this is what I was talking about. The original stuff, the containers, the EC2, ECS, that stuff is good, and there's economies of scales there that make it cheaper than running your own data center and your own services there. Lambdas are where things start to get silly for me, at least. Some detections we've some decisions we've not yet taken. Some decisions we've taken are not obvious, but they resulted in significant improvements. For example, we replicated a computationally expensive media conversion process and placed it closer to the detectors. Whereas running media conversion once and caching its outcome might be considered to be a cheaper option, we found this to be not cost effective. And caching its outcome might be considered to be, huh? Wait. For example, we replicated a computationally expensive media conversion process and placed it closer to the detectors. Whereas running media conversion once and caching its outcome might be considered to be a cheaper option, we found this to not be. How is that true? What does that mean? Are you saying that disk is expensive or something? Okay. The changes we've made allow Prime Video. Like, where are they staging the output of that? Right. That's what I'm wondering. If you've got a as let's say your disk in this case, you need some buffer, some place to stash the intermediate thing that's available to downstream processes. If is that S3? Is that why it's expensive, or like could they not just use a SAN or something like that, right? Um, the changes we made allow Prime Video to monitor all streams viewed by customers and not just the ones with the highest number of viewers. This approach results in even higher quality and an even better customer experience. Great. Okay, this is a great article. Great article. Well done. Well done, Amazon. I applaud them. There was some. I saw this reaction. Donnie Burkles wrote, "This post is an absolute embarrassment for Amazon as a company. Complete inability to build internal alignment or coordinated communications." And I don't know if that's true. If I'm honest, I am surprised to see this article, but I don't really think it paints Amazon in all that bad a light. Actually, it's just sort of saying something that I think is fairly obvious, which is there are different strokes for different folks, right? Like different use cases require more care and consideration than others, right? And you have to like let your use case inform your architecture, right? And of course, this guy who, oh gosh, David Hannemeyer Hansen, whose opinion I I tend to just if I multiply it by -1, right? Whatever he says, I just go the opposite way usually. Um, and of course, look at him. He's just reveling. Oh, that's why this thing blew up, is because he posted this a couple days ago, a few days ago, 3 days ago, but this is a blog from a few months ago. Okay, that's why this thing just hit right now. It's because of this blog. I get it now. I get it. The Prime Video at Amazon has published a rather remarkable case study on their decision to dump their serverless microservice architecture and replace it with a monolith instead. This move saved them a staggering 90% on operating system costs and simplified the system too. What a win. Okay. Again, there's just a lot of like, look at this. Look at the way. I'm happy that we beat back the zombie onslaught of that terrible idea for the third time in my living memory, but we still need to stay vigilant that we'll eventually have to do it again. Some bad ideas simply refuse to die no matter how many times you kill them. All you can do is recognize when they rise from the dead once more and keep your rhetorical shotgun locked and loaded. Is he talking about fascism? Because I don't know what he's talking. He's actually talking about monoliths here, people. Like, this is not like, this is insane, right? Like he really he's talking about microservices. He thinks that's the thing against which we need to stay vigilant, right? Which is, again, do I need to say it? It's it's also you can't just say one thing is the right thing all the time. That will never serve you. And it is a little I don't know, predictable that David Hannemeyer Hansen, the creator of Ruby on Rails, the framework that has contributed more to bad monolithic code than any single technology in the last 25, 30 years, would have this sense, right? Would have that sort of like insight, like, why would he? Of course, he would argue this, right? Of course, he would have that ridiculous perspective. Very, very sad. Makes sense that, oh, so what are we saying here? We're saying makes sense that long running and computationally expensive operations don't do well in Lambda. Yeah, no kidding. Like, if, it's expensive to start a separate VM. It's your code is not your code is a problem, but the cost associated with running your virtual machine, you know, most lambdas have a limit of memory right there. So if you're fitting within that limit and everything is the defaults, then it's going to be pretty standard. It's just the length of time you're using that computer, and they charge you for that. It's a new computer for the time you've got it. Um, okay, so but he does say something. Look, so DHH does make one interesting, again, painfully obvious point here, which is replacing method calls and module separations with network invocations and service partitioning within a single coherent team and application is madness in almost all cases, right? But he does qualify it with within a single coherent team. See, and this is actually what I've always been saying, right? For the last, since, I don't know, 2013 or whatever. If you've ever seen me do a talk about the microservice architecture or microservices, I've always tried to impress that the sort of threshold where you might consider microservices are when you have a team that is large enough where it behooves you to improve communication patterns between those teams, right? Or between the team, right? The people in the team. And this is the true threshold. It's not a technology discussion, right? Break apart your monolith when the team becomes too big. There's no other reason to do it, really, right? You're adding complexity that will make life more painful. The only reason you should do it is when the scope, the domain of a particular thing grows big enough that it becomes useful to sort of break them apart into smaller teams so they can have faster iteration, so that you're not beholden to everybody else in the team. If you don't want to, if you have 100 people working on the same code base, then by definition, you have to wait to stabilize, integrate, and deploy every little thing, which means that your rate of change drops significantly, right? That reduces your ability to respond to change in a dynamic marketplace. That's why you do microservices. It has nothing to do with like, I want a service like SOA. I didn't like SOA. Building a microservice, building an API on the internet, just because you want to reuse it or something like that. I never, you can link libraries together. We have that for a reason, right? What I care about is unblocking teams. I want them to be able to go fast, deliver things into production. And so if you have a small team and everybody's on the same group, then yeah, go, don't bother with the microservices. It's fine. Just use well-organized modules, not Ruby on Rails, right? That's the anti-pattern, right? That's the thing, that we can all agree isn't working, right? If you find yourself writing this code, like, that, and then models, and then whatever, what is it? Model views, whatever. If you find yourself writing that code, app dot whatever, like in Rails, then you're doing it wrong. Okay, don't do this. You've just built the worst code base possible. And in fact, you might be better off in this ridiculous case by, if you don't understand what's wrong with this and you don't know how to fix it, go ahead and build microservices so that you can understand how things get layered and how the services might communicate, and then put it back together, right? Because they won't end up in the same package like that if you're building several different services, right? Put them back together, right? But only you go through the exercise of having things communicate in terms of their boundaries, their module boundaries, instead of like this ridiculous, controllers, models, and views and whatever. That's a Ruby on Railsism that just needs to go away. It's not conducive, right? If you want, so I guess what I'm trying to say is here, friends, the lesson here is you should think before you embrace an architecture, and definitely don't listen to this person. Clearly, please, just like I cannot think of a more ridiculous take on this. What else? He says, in many ways, microservices is a zombie architecture. What does that mean, guy? Like, what does that mean? Another strain of an intellectual contagion that just refuses to die. It's been eating brains since the dark days of J2EE. Remember server beans, anyone? Okay, that's not microservices. through the WS Death Star. That was SOA. And again, this is yeah, nobody liked soap, but what does that have to do with anything? Through the WS Death Star nonsense, and now in the form of microservices and serverless. Okay, another strange. So, okay, his clearly. Okay, fine. Um, hmm, what do we got here, friends? We can even break the code into modules before going to micro. Yeah, of course, right? That's what this is. Like, so modulets, spring, right? We've this is a project. This is a project that you should check out. It's awesome. We've this is a from our very own Oliver Dotbaum. He's the former lead of Spring Data, an amazing engineer, and he's done just an uncanny amount of work around making moduliths elegant. There's no reason that you can't have moduliths. You know, a modular monolith. That's called a modulith. Get it? And there's a project. We even have a project. It's a Spring project now. It has long existed as one of his projects, right? It was Oliver's project for a long time, but it's very useful for years. It's been useful and usable for years, and I even had him on the show, right? All beautiful podcast, right? Let me see, all episodes. Oliver, was he on this year or last year? Let's see here, friends. Um, Gosh, this podcast, Oliver. Yeah, he was on the show in February of last year, for example, talking about this stuff, right? About elegant architectures. This is a great episode, by the way, friends. If you want to listen to a really, really amazing human being talking about um, how to build architecture, definitely check out this podcast with Oliver Dropbaum from February of last year. It's amazing, but and that project has now been turned into an official Spring project. We announced it last October. So when designing software systems, architects and developers have plenty of architectural options to choose from. Microservice-based systems have become ubiquitous in the last, well, I don't know about couple, but yeah, they've become ubiquitous in the last decade. Okay, let's say 2009 onward. However, the idea of monolithic modular systems have also, I would say, mercifully, regained popularity. Independent of the architectural style ultimately selected, the individual applications comprising the overall system need their structure to be evolvable and able to follow changes in business requirements. There it is, people. Boom. That's what it is. That's exactly the right way to think about this. Can you build an evolvable system, right? Microservices are one way to do that if you have a large enough team. But if you structure your code in the right way and build it in such a way that you don't code yourself into a corner, maybe you can do it this way. Traditional application frameworks have provided structural guidance by providing abstractions aligned with technical concepts, such as Spring's stereotype annotations, at controller, service, repository, and so on. However, shifting the focus to align code structure with the domain, right? Dan North, right? Another, you know, agile test luminary, domain-based. He talks about domain-based systems, right? And domain-based architectures, right? However, has proven to lead to better structured applications that are ultimately more understandable and maintainable. Until now, the Spring team has given verbal and written guidance, and so much verbal and written guidance on how we recommend structuring your Spring applications. We decided that we can do more than that. Spring Modulith is a new experimental project that supports developers in expressing these logical application modules in code and in building well-structured domain-aligned Spring Boot applications. An example, okay? And by the way, this is cool. You can check out this code yourself here. I'm going to pay. Oh, that's sad. What just happened? That link is a 404, but here we go. I'm going to paste this in ye old chat, okay? Minimize. Paste. There, look, there's the link. Grab that link when you can. Simon says I just realized that's okay. Anyway, Simon says I'm using Modulith at my new client, and it works well. Great. See, that's awesome. Like it's already out there. People are using it with success. Yeah. Let's see here. But having a few microservices following the microservice architecture principles in preparation of future scale, is that a bad thing? No. But again, you can, again, if you're, um, you want to when you build a new application, you start with a small team and a small code base, and so your problem there is not going to be scale, right? In any sense, you're not scaling the team, nor are you scaling the service, right? You don't have, presumably for most people, you don't have you're not going to get on, you're not going to be on the front page of Slashdot or Reddit tomorrow, and your service isn't going to need that scale. So you should just build the right service as a monolith. That's just the natural way to go. That way you can thrash and make decisions and rework things out, and so on. Where things get problematic is when you have lots of people working in the same code base. Now they all need to communicate about every little change. There needs to be synchronization across this large team. That creates bottlenecks, and it means that things become undeliverable, undeployable for longer, right? You want to reduce that by isolating these things from other people, right? So the smaller the team, the more readily you can make changes to any particular component in the system. But that's not a thing that people like. I would argue that for a lot of people, a lot of organizations, you're never going to get to that point. So much of software fails. It doesn't get big enough to justify that jump to microservices, right? So start with a monolith, do it with a modular fashion, do it in a modular fashion using something like Spring Monolith. And then if you are lucky enough to get to the point where you need to scale out your team, then decompose, right? It's going to be much more natural to do that if you're using a Spring modular style approach, right? Um, yeah, so yeah, it's absolutely no problem to use microservices. But again, microservices by their very definition um, introduce logical boundaries. They introduce physical boundaries on top of your already logical boundaries, and that makes it makes it harder to reuse and harder to change things around. So do all that initial like thrashing where you're really sketching out the idea. Do that in a monolith as early as possible, and then only when some designs have sort of firmed up and cemented and your team is large enough that this becomes useful, yeah, only then decompose, right? Okay, so you're continuously updating the version, though, given that they are still updating or adapting some detections. Luckily, no major upgrade issues so far. Great, right? And it's a point 0.5 release for Spring Modular. It's not GA. There's going to be some turbulence, as with all new code bases, but this is important, right? Like it's good to have something like that available. So this project, by the by, it is informed by Oliver's vast um, uh, efforts around architecture, right? So for example, if you ever used Spring HyperOS, Hypermedia as the engine of application state, about which, by the by, we spoke when we looked at in the Let's Code series for Spring Boot. If you've ever used that, then you're using something that he helped bring to the table, right? And he's also got a bunch of other work that he's doing beyond Spring to sort of define architectural primitives, and he's just a really interesting cat, really interesting human being doing amazing things. Let's see. We did Spring Boot Monolith last year, now going to make domain model microservices. Wish I had known Spring Modular. Well, it's not too late, right? But again, you can't just take Ruby on Rails code and what you got to do is it is a prescription around architecture. It's a prescription around how you structure your domain and your services in your system, right? The components in your system, in your architecture. So it is not just a magic annotation. It is follow these principled design decisions and choices, and you'll get to a system that behaves better, promotes evolvability, is cleaner, requires less cognitive load, etc. Right? And that's for a lot of people that might be a turnoff, right? It might be, hey, this is work. I don't want to do work. I've already got a job, but I think it's worth it. I think it's definitely worth like learning about this stuff. And maybe you know what? Maybe I should do a Let's Code. Wow, what is he doing? Look at that. Oh, 5 days ago. Look at that. That really is one of those things that's just changing by the day. Promoted project out of experimental status. Everything just got moved 5 days ago, right? Wow, okay. Yeah, okay. So create a Spring Boot application. Create a Java package arrangement that puts business modules as direct sub-packages of the application's main package, okay? So source main Java, example.inventory, example.order, okay, great. Again, you're packaging by feature, not by role, right? The application root package, the application module packages. Create an application modules model, run verifications, and create documentation snippets. See? Documentation is good architecture. Uh, Create a test. So write documentation snippets. So application modules of application.class, verify. New documenter, write modules as plant UML, write individual modules as plant UML. That's so cool. That's so cool. Creates application module and verifies its structure. Renders ASCII doctor snippets, component diagrams, application module canvas, etc. Run integration tests for individual application modules. Let's see. Okay, order module integration tests. Yeah, test, blah, blah, blah. Okay, you get the idea. I'm not gonna, this is not a let's code Spring modules. We will definitely, I think we definitely need to do one of those. It's, now that it's no longer experimental, it seems like it's a good idea. So what do you think, people? What do you think? Did we learn anything new here? Hopefully the answer is no. Hopefully you didn't need to be told that you should think before you deploy or build an architecture. I can't believe this is like a thing, this is really kind of sad because I know, for example, that I have spent the better part of the last decade talking to people about agile and building services in response to a need to change, right? It's no, and even Netflix, again, that was the original use case there. Netflix wasn't trying to build microservices for like they weren't, it wasn't about I just need more SOA, right? It wasn't about I would like to have more network traffic. That wasn't the use case there, right? So, hey, Daniel, that's great. I'm glad you got something out of it. Thank you for joining. Thanks for hanging out, everybody. Spring Roof for the win, I guess. I'm not sure what you're saying, but I appreciate it. Spring was cool. I miss Spring Roof sometimes, but it had its day. Spring Boot for the win, on the other hand, is good stuff. Thanks. Today is like a gateway to Spring Monolith. Yes, it is. Hell yeah. Wait. That's a good point. I'm not going to diss Rails too much. It gave us a lot, but it also took away a lot. And I'm just trying to unwind some of those bad opinions. It's good to have opinions, right? It's good to have opinions that are loosely held, strong opinions loosely held. And Spring Boot is that thing. It gives you strong opinions, but they're loosely held. You can unwind them all the time, right? By just overriding a type, by providing a bean of a particular type or providing an interface or whatever, right? The AHH problem is many orgs are moving out of Ruby Rails. I mean, yeah, I think he's just hopping mad that his thing had its time in the sun and it's moving on. By the way, that's a good point. Ruby on Rails was like 2005. Here we are, 2023. It's been around and it has served us well for a long time. It's certainly made Java better in the sense that we have this now standard thing, which is convention over configuration, right? I love convention over configuration. But the problem with Rails has always been that convention was sort of, immutable, inflexible. You couldn't unwind some of those decisions without going all the way down to basics again. So Spring Boot, I think, kind of gave us the best of both worlds. But it took a long time. It was a hard lesson for a lot of us to learn. All right, friends. I think we did it. I think we just had a conversation that was fun. I'm gonna go to dinner. It's Greece. I mean, I don't know if you can't even see it, but the sun's out. It's beautiful. Not a cloud in the sky, So yeah, have a great one, everybody. Thank you.